This AutoMQ introduction video will include the following sections. AutoMQ is a cloud-first designed alternative to Apache Kafka, while ensuring 100% compatibility with Apache Kafka. AutoMQ can help users reduce over 90% of Kafka costs and achieve a 100-fold increase in elastic performance by offloading persistence to S3 and EBS. AutoMQ, with its innovative features such as partition reassignment in seconds and traffic self-balancing, can enable the cluster to complete automatic elasticity in seconds, significantly reducing the operational complexity of the streaming system. Users can get the source code of AutoMQ from Github and use the free community version, or use the commercial version of AutoMQ. If you are looking for a more cost-effective, high-performance, and elastic Kafka service in the cloud, don't miss AutoMQ. AutoMQ has reformed the storage layer of Apache Kafka based on a cloud-native shared storage architecture. The AutoMQ automatic controller is responsible for monitoring, collecting, reporting, continuous self-balancing, and automatic elasticity. The Stateless Broker forms the computing layer, and the storage layer is implemented based on EBS wall and object storage. S3 Stream is a new generation of stream storage library implemented by AutoMQ based on object storage and block storage EBS. The storage layer significantly reduces storage costs through inexpensive object storage. The computing layer reduces the cost of the computing layer through Stateless Broker, automatic elasticity, automatic traffic rebalancing, and the application of spot instances. The storage architecture based on shared storage not only brings extreme cost reduction, but the extreme automatic elasticity also makes AutoMQ easier to maintain and operate compared to Kafka. In addition to providing a fully managed SaaS cloud, AutoMQ also offers a BYOC deployment mode with higher security and data privacy. Users can deploy the AutoMQ BYOC environment with one click through the marketplace of the Cloud Market or Terraform. The AutoMQ console, responsible for cluster resource management, and the data plane AutoMQ server are all deployed in the user's own VPC. The user's log and metric data will be stored in a separate operations bucket. When the AutoMQ cluster encounters problems and needs support from AutoMQ technicians, the user only needs to authorize the operations bucket to AutoMQ across accounts. Then, the AutoMQ management platform can help users analyze and diagnose problems based on the logs and metrics in the bucket, and execute online technical support through the AutoMQ console's web shell. Next, we will demonstrate how to manage AutoMQ clusters deployed in BYOC mode through the AutoMQ console. Show how to quickly achieve side effect-free cluster capacity scale in and scale out on AutoMQ. By utilizing its innovative features such as partition reassignment in seconds and automatic traffic self-balancing. The first demonstration is cluster creation. In the console instance list page, select the instance from the sidebar, then click Create Instance to create an instance. After filling in the necessary information, we can choose to deploy the AutoMQ data plane to the same VPC as the console. When choosing a subnet, you can choose to deploy in multiple availability zones. Here, for the sake of demonstration, we choose to deploy in a single availability zone. At the bottom, we can choose the compute specifications. The compute specifications of the AutoMQ data plane are represented by AKU. AKU determines the max read and write throughput, partition, request per second the cluster can handle. AutoMQ uses object storage as the primary storage. And unlike Apache Kafka, it does not need to reserve storage resources and adopts a pay-as-you-go payment method. Finally, confirm the preview information provided by the console, and click Confirm to complete the creation of the cluster after confirming that it is correct. Next, on the instance details page, we can view the basic information of the cluster and obtain the access point information of the cluster from the overview page. On the instance details page, you will be very familiar with these configurations. AutoMQ is fully compatible with Apache Kafka. so you can modify and use AutoMQ's configurations, just like you modify Apache Kafka's configurations. In addition, the console can also view information about nodes, topics, and consumer groups. The integration capability of the console allows the expansion of AutoMQ's capabilities. AutoMQ supports pushing metrics to self-built or cloud-hosted Prometheus or AWS CloudWatch. It can also integrate with other Apache Kafka clusters and with the built-in migration capability. It can help users to complete the data migration and switch from Apache Kafka to AutoMQ in a fully managed way. On AWS, you can integrate with CloudWatch to monitor and alert AutoMQ. Here we demonstrate how to integrate AWS CloudWatch. Create a new integration on the integration page, select CloudWatch, and create an integration instance with a custom namespace. Then, on the AutoMQ instance details page, select Integration, check the CloudWatch integration instance you just created, and complete the binding association. In this way, the AutoMQ cluster instance will automatically push metrics to CloudWatch after it runs. On the console, we create a test topic with 32 partitions. Thanks to AutoMQ's full compatibility with Apache Kafka. When creating a topic, you can also choose to set all the parameters supported by Apache Kafka. Within the same VPC, we have prepared an EC2 as a client to demonstrate basic data sending and receiving. Copy the access point information from the AutoMQ cluster instance details page. On the client EC2 machine, we have constructed simulated traffic and completed consumption using the perf tool provided by Apache Kafka. Next, we start the producer and consumer, and apply a traffic of 150 megabytes per second to simulate a scenario where the cluster capacity is insufficient and needs to be expanded. On the instance details page of the console, we can see basic monitoring information such as throughput and storage space usage. We can also further check the details of the topic instance, and observe the consumption situation of the consumer group. We have previously completed the integration of AutoMQ with CloudWatch. Therefore, on CloudWatch, we can now view the lag situation of the consumer group, as well as key monitoring indicators at the topic and instance level, such as the value of bytes in and out per second, etc. Users can also directly use the capabilities of CloudWatch to configure their own alarm rules. On the cluster instance details page, we can see that, under the effect of the AutoMQ self-balancing component, the traffic is kept balanced among the various partitions. Next, we click on Resize to scale out the AutoMQ instance cluster. The current cluster uses 6 AKUs with 3 nodes. After clicking Resize, we select 8 AKUs, adjusting the cluster's throughput capacity from 120 megabytes per second to 8 AKUs 160 megabytes per second. After clicking Confirm, the cluster will start to scale out automatically. During the scaling process, we will see some warning logs on the client side. This is the AutoMQ's self-balancing component scheduling partitions among brokers to balance the traffic. Unlike Apache Kafka, which requires a self-designed migration plan and takes hours to complete the replication of partition data, thanks to AutoMQ's feature of reassign partitions in seconds. AutoMQ don't need data replication and not exists cross AZ fees. The client can continue to send and receive messages without any perception of the process. On the console, we can observe the traffic acceptance situation of the node, and find that the newly expanded node quickly completes the automatic traffic balancing. The introduction to AutoMQ ends here. If you want to experience AutoMQ for free, you can refer to another installation video based on Terraform on our YouTube channel, or contact us through the official website. Thank you for watching.